Hello. Unit 5 is about ionic and covalent compounds, and a huge part of this unit is naming these compounds properly. But because there are several types of ionic and covalent compounds, a good way to tackle this problem is to first be very good at categorizing the types of compounds that you have. And this video is concerned about categorizing these types of compounds. Thus, we are not going to learn the rules for naming each of these compounds. The purpose of this is to get a framework as to how we can categorize the compounds so then naming becomes much easier. And this whole part of the unit, we are concerned about the proper, called nomenclature, of compounds. Nomenclature, Nomenclature. Okay, that's just a fancy word for naming, proper naming of compounds. That will be discussed in future videos. Here, I want to categorize the type of compounds that you will have to name. And a good system is we're going to start with A. And A are the binary ionic compounds. Binary, ionic compounds. Now, you probably know that ionic compounds are compounds that are between ions, and the first ion listed would be the metal ion. But the thing is, there are certain metals, when they become ions, have a specific charge, and we'll call those invariable charged metals. Thus, we have actually two categories of binary ionic compounds. That is A1, which are the binary ionic compounds with invariable charge metals. And that's technically our first category, category A1. Examples of those could be MgO and Al3N2. Why don't I name those? But again, the rules for naming these will be in future videos. But probably you'll see, or you'll be able to discern the different rules for these compounds. So this is magnesium, space oxide. If you know the rules already, you could test yourself. This is aluminum, nitride. The second type of binary ionic compound is those made with variable charged metals or variable charged metals. A2. Those are typically the transition metals. This is our second category. It'd be nice to have a periodic table handy. The invariable charged metals, the A1 type of metals, are group 1, starting with lithium down to francium, beryllium down to radium. This is group 2. And 4 other metals that are not in group 1 or group 2. These 4, Ag, zinc, aluminum, and cadmium. All the other metals, you can 95% of the time safely assume that they are what's called variable charged metals. And let me give you a couple examples of those. I'll give us CuO and Fe3N2, another one that has 2 nitrogens, Fe3 and 2. Look at the difference in the naming. This is copper, parentheses, Roman numeral 2, space, oxide. Again, we're not going to get too deep into the how to name these. I just want to give you some examples. But that too refers to the charge of this copper. This is copper 2 plus. Same thing with iron. Iron is a variable charge metal. Therefore, in the name, they have to give us the type of iron. And again, this is 2 charge, 2 plus, iron 2 plus, and this is nitride. Since I've mentioned that the 4 non-group 1 and non-group 2 metals that are in variable charge are these 4: silver, zinc, aluminum, cadmium. Where do they belong? They belong with A1. So let me put here actually where these invariable charge metals are. They are what? They are group. We'll call this group. I think most periodic tables call it group A1, the first column, but we'll just call it group 1 and 2. But what else? Silver, and I'll tell you now that silver is always plus when it becomes an ion. Zinc, 2 plus. Cadmium, which is under zinc, also 2 plus. And aluminum, which is considered a metal, 3 plus. Okay. Yep, just be careful. Don't mistake in aluminum. That's not a metalloid. It is clearly a metal. Right? Clearly a metal. Okay. Next category. Category B. As you could tell, before we move to category B, as you could tell, the main difference in naming between binary ionic compounds that are of category A1 versus A2 is that there's the Roman numeral for the variable charge metals. How about B? B will be, this depends on the textbook or your professor's preference. I'm going to go with binary covalent compounds. By the way, ionic, look at our examples. Ionic compounds are those between metals, plus, in this case, nonmetals. Or, yeah, we'll just put nonmetals. We'll see, actually, category C will also be ionic, but we'll get to that after category B. Binary covalent compounds. I wanted to discuss ionic compounds as metals plus nonmetals because covalents are only going to be nonmetals. Examples of those are going to be N2O5. And let's pick CO. All right. Dinitrogen, space, pentoxide. The next one is carbon monoxide. Definitely you would want to read up or review your professor's notes or watch a video that helps you learn how to name binary covalent compounds because there are some tricky ones, but we're not going to go over those rules in this video. Okay. For instance, why do I put a di here for the 2 nitrogens, but I don't put a mono for the 1 carbon? Things like that you want to be clear of before you take the exam. So that's binary covalent compounds. Category C. Category C, we're going to have something called polyatomic ions. Polyatomic ions are interesting because they are made of nonmetals via covalent bonds, but they are ionic. So that's kind of a mouthful. but they are made of nonmetals via covalent bonds, and they have a charge and charge. An example of that, let us pick up, what do I want? Let's do SO4, 2 minus. This is called sulfate. See, this is our first compound that's actually an ion. That is charged. The other thing, I know I keep telling you I'm not going to talk about this, but the other thing that we're not going to go over in this video is what's called Lewis structures. Like, how are these atoms arranged to each other? How are they covalently bonded to each other? That actually is in a different unit. That's unit 6. For now, you are expected to memorize the chemical formula and the name for a bunch of polyatomic ions. Let me give you one that's a cationic. Cationic is something like NH4 plus. That's called ammonium. That's a H, ammonium. And we're going to make ionic compounds out of these polyatomic ions. But again, it's going to depend on whether we have invariable charge metals or variable charge metals, how these are named. Now, I forgot to put a green box around B because there's no subset for B. So far, our categories are binary ionic compounds A1, binary ionic compounds A2, and binary covalent compounds B. C, C is not I wouldn't call it, it's not an ionic compound, not yet at least. It is covalent and is charged, so yeah, we'll put a box here. Obviously, you'll have to know how to name these. But now when we start making ionic compounds, we're going to hook up a metal to the anions. So for instance, we'll call this C1. Again, we're going to look at invariable charged metals. And let's take sulfate. This is interesting. We do want to make sure that it's balanced when we make these ionic compounds. And let's take, for instance, lithium. Lithium 2 sulfate. Since it's invariable charged metal, lithium, no Roman numeral. Lithium space sulfate. Okay. C2, again, will be variable charged metal. C1, C2. Okay. Let's pick a variable charged metal. Easiest thing to do is to look at your periodic table, and let's take, have we done a copper yet? Let's take, actually we have done copper. Let's take cobalt, CO. CO, and look at this, NO3, 2. We have parentheses now within the chemical formula because we need 2 nitrates to balance out this cobalt. Well, that cobalt has to be 2 plus then. If you don't know very well yet your polyatomic ions, this would be hard because you may not know that nitrate has a -1 charge, a negative charge. Okay, and since we need 2 of them, that implies that cobalt is 2 plus. This polyatomic ion nitrate is called nitrate. Okay. Now there is one thing that doesn't require a metal. It's if your polyatomic ion is positive. Okay, so simply let's take ammonium chloride, NH4. So this is a category unto itself. There aren't many actually polyatomic ions that are positive, but really all you have to do is name the components. Ammonium, right? This will not be variable charge. Your polyatomic ion that are cationic will have a specific charge. Ammonium chloride. So just name the components. All right. Okay, I'm good with that. Last category. We'll call this category D. Actually, second to last category. Um, these are the acids. And actually, I don't want to square the D um, because there are two types of acids that we need to know how to name. D1, those are going to be what's called the oxyacids. Acids that have oxygen in them. You'll read up on acids because I'm not going to get too deep into them. Acids are molecules or compounds that release H plus when dissolved in water. And an example of an oxyacid, oxy meaning oxygen, is HClO3. You notice that this part is a polyatomic ion, chlorate. When we add enough hydrogens to negate that negative charge, we get the acid. This is called chloric acid. And I'll put in parentheses from chlorate. What's chlorate? ClO3 minus. That's an oxyacid. The non-oxyacids would be category D2. Sometimes in the textbook they are called binary acids. Because the vast majority of cases, the non-oxyacids are only two types of elements, hydrogen and a nonmetal. There's one exception that I know of. I'll actually show you that in just a bit. But a non-oxyacid or a binary acid, the classic one is HCl. That's gastric acid, and that's called hydrochloric acid. The main difference between the oxyacids naming and the naming of non-oxyacids is the addition of this prefix hydro. Okay. One non-oxy acid that's not binary, that actually has three different elements, is HCN, and that's called hydro, because it's still not an oxy acid. So we are going to use the prefix hydro, cyanic acid. It comes from the polyatomic ion cyanide. But the main point is that you have to put hydro. Okay. Just as a little tip, this is very common on an exam because it's tricky. You have chloric acid, HClO3, and you have hydrochloric acid, HCl. Another trick, I'm not going to write them down here, but there's an acid called sulfuric acid, and there's another acid called hydrosulfuric acid, and you would have to know how to draw the chemical formula. Okay. The last category, E, and there's no subset for E. These are just the hydrates. Hydrates is you take an ionic salt, for instance, do I have one up here somewhere? Okay, maybe lithium 2 sulfate. I don't know for a fact whether this forms a hydrate, but I'll give you an example what to look for. A hydrate is something that has a dot after it's normally a ionic compound with a polyatomic ion, followed by a dot, and with a number of water molecules, and I'll put here 4. Again, I doubt this is actually real, but that's the format. Okay, the salt, number, and number of water molecules, because that's what a hydrate is. It's been hydrated. The salt has been hydrated. You know, there are some salts that suck up water from the atmosphere. Those are like dehydrating agents or desiccants. Okay, so that's an example of a hydrate. Oh, I never named it. Lithium. Just name the salt, lithium space sulfate, and then you're going to use the prefix. The Greek prefix here is tetra, mono, di, tri, tetra, penta, hexa, but this is tetra. Tetrahydrate. The base is hydrate. Lithium sulfate tetrahydrate. Okie dokie. Those are your categories. Again, I didn't go over specifically the rules. Everything in blue, I told you the name, but I pointed out some differences, but I didn't go over the rules formally. Those are, you could get that from your reading or some future videos. But let me show you the categories again. A1, A2, B, the one with the mono, di, tri, etc. C, learn your polyatomic ions first, and then put them together into ionic compounds. Okay. Ionic compounds between metals that have invariable charge or variable charge. D, you're going to take those polyatomic ions and make them into oxyacids. Let me just, oh, well, here. There's a polyatomic ion right there. Or maybe I could just put a little bracket here. This is the polyatomic part. And then lastly, hydrates. You take a salt, probably from category C1 or C2, and if it sucks up water, you're going to put a dot plus a number of water molecules that it complexes or adheres to. All right, those are your categories. Good luck. Again, I think you'll be able to name these compounds better if you can categorize them in your head. Know whether there's an invariable charge metal or a variable charge metal. Know whether it is binary covalent or binary ionic. Definitely know if you have acids, and then you can start using the rules that dictated these names. Okay. This is all part of the nomenclature of compounds.